Hi, everyone. Seems like we're ready to get started, so let's get right into it. I'm Megan, and this is Ashvin, and we'll be presenting today on Qualcomm AI Hub, which is how you optimize, validate, and deploy ML models on device. So just going quickly over the agenda, we'll talk a bit about why you should bring your models on device, as well as what Qualcomm AI Hub is, before we show you how to use it, and then we'll go into a bit of a hands-on deep dive towards the latter half. So if you want to try it out in real time, or you have any questions from the material that we've presented, we're here to answer all of them. So we'll jump right into it. So first things up is why on-device AI? We know that there's AI experiences all around us. Of course, AI is becoming more and more popular, whether that's text-to-speech on your phone or taking a photo and ML models running in the background to make sure that the photo turns out just right. Even chatbots are becoming, popular in pretty much every app these days. So I'm sure you've seen lots of different ML experiences, but we want to make it more popular for you to bring those into your application without it being complicated. So not only experience ML in your everyday life, but also develop it yourself and bring it onto the devices that you're looking to deploy to. With that, our goal is to make every product, application, and device more intelligent. So before we get into how we're going to do this, we'll talk a bit more about why we think it's important to bring this ML on device. So there's three main reasons: cost, privacy, and performance. It's pretty self-explanatory, but if you're running the model using the power of a smartphone or a laptop, a drone, or the chipset in an auto device, then you don't have to be running everything in the cloud. As a result, there's no cloud costs, so you're saving money there. The next piece is privacy. So if the model is running on your device, then any of the data that it's processing, whether that's the question that's being asked to the chatbot or the image that you're trying to do image classification on, it doesn't need to be sent to the cloud. So if there's private data in that image, let's say it's a person's face, then that data isn't being shared with whichever cloud provider that you would be using otherwise. And then the last piece, which is very important, is performance. So instead of running a model and having to send it to the cloud, get the results, and then it being returned to your device, things can happen in near real time by using the device that you have in your pocket or right in front of you. You can use that chipset and take advantage of all of the capabilities that it has. Specifically, when you look at the chipset, you can run machine learning models on the MPU to get the best performance. So we focus on helping you take advantage of the MPU. Of course, if you want to run your model, let's say you have a gaming application that's taking the GPU and you're okay running your ML model on the CPU and the MPU, you can specify that as well. But what we found is, because it's designed for it, the MPU is where machine learning applications run best. So we help make sure that happens without you having to do a lot of complex math or figuring out what ops are supported in the background. So why is deploying on device so hard? Right now, it's a bit of a complicated problem if you try to go and solve this on your own, because there's different languages that you could use. You could have your machine learning model in TensorFlow or PyTorch or Onyx, and then you have to figure out what ops each of those platforms support, and then you have to try to bring it to the device depending on which runtime you're using. It might not be optimized for the device specifically. So maybe the model doesn't even run. Maybe it hits an op that isn't supported. There could be the model running and then not providing the bounding box or the classification that you want it to. There's just a lot of different problems that could occur. And to have to create a knowledge base within your team or within yourself to figure out all of those different complexities is a lot of work. So that's where Qualcomm AI Hub was started to help solve these different pieces so you can focus on making sure that the model is performant and that it works for your application. Then you can spend more time worrying about what it's doing and can it do more? Is there more AI application or more AI that you could bring into your application to make it better instead of worrying about all of the details here? So there's three main pieces that Qualcomm AI Hub helps with. The first is getting started. Of course, I've talked to you about the benefits of on-device AI, but if you don't know where to get started, then it's a lot for you to figure out. The second piece that it helps with is making sure that you're deploying one model across many devices. So we want to make sure that you're deploying an optimal model, but also that it works regardless of what phone a user has. So you don't want to have to create a new model rather, for every device that you're looking to deploy to. And then you can just use the one model that you've optimized and bring it across the devices that your users are interested in or that they have. And then the last piece is rapid iteration. So there's a lot of open source models out there today that you can go and use, but they might not be super performant, or maybe they don't meet the benchmarks that your team have set in place. So if you need to be under a certain latency or a certain memory bar, we help you so that you can figure out not only what is happening, how much memory is being consumed, where the latency is coming from, but we get it all the way down to the op level, so you can visualize the model, see what's going on, and see where the potential bottlenecks are. So you can continually improve your model until you're happy with it, and then bring it on device. As a result, we like to think that Qualcomm AI Hub makes it easy for you to bring ML models on device. And this is across mobile, auto, compute, and IoT chipsets. So you don't have to worry about figuring out all of the complexities regardless of which device you're looking to deploy to. Now, there's a couple pieces of Qualcomm AI Hub that we recommend depending on where you want to get started and what path you want to take. So the first piece is AI Hub models. This is our collection of pre-optimized models. We have 250 or more than 250 models that you're able to select from across a wide variety of popular use cases. So this is everything from image classification to object detection, as well as some Gen AI models. Hopefully you can find something in our collection of pre-optimized models that works for your use case. If you don't, that's perfectly okay. If you have your own model that you've already trained, or maybe a model from GitHub or Hugging Face that you think solves your use case, that you fine-tuned with a specific set of data, you can then bring that to the middle box, AI Hub, which is our platform. You can submit the model, and Ashvin will show you in just a minute how to do that. And then you can see that we give you an optimized model that you can download and bring into your application. If you don't have an application or you want to see how to configure the target runtime, that's where AI Hub Apps comes in. We have a very select set of sample apps that help you understand how you drag and drop our model into your application. So that way you can see the performance that you're getting on our platform in your application, or in this case, in the sample app. So it just helps you get started. As I mentioned, we have a wide variety of models that are pre-optimized, and this is across quite a few different chipsets, like I mentioned, and then we also have our ecosystem of partners. So these come across two different areas. On the left, you'll see our model makers. So if you have a large language model that you've seen doing really well, we have a lot of popular model makers like Mistral, Tech Mahindra, Preferred Networks that have licensed their models to be distributed through Qualcomm AI Hub as well. So you can always visit them there and then reach out to us and we can help you use that model. The other piece is our service collaborators. So if you want to make your own model, but you don't have one yet, you can use some of our partners like Amazon SageMaker, and you can go ahead and build your model, fine-tune it, and then bring it to us, and they've directly integrated into Qualcomm AI Hub. I won't go through all of the partners, but you can, of course, check them out there. We have some that are no-code and low-code solutions so that you can create your model and then come to us for the optimization piece. One other thing I wanted to talk about before I hand it over for the demo is a little success story. So this is one of our Qualcomm AI Hub first users, and the company's name is Full Track AI. They were using Qualcomm AI Hub because they were creating an app for sports analytics, and unfortunately, when they initially created the model to do object detection for the cricket pitches, they were trying to provide feedback to the users, but the phone was overheating so much from the model that they couldn't use it on device. So they were sending it to the cloud, recording the practice, and then having to wait to see the results because they just truly could not deploy it on device. But they ran the model through Qualcomm AI Hub using our Bring Your Own Model solution, and they were able to reduce the latency by 50x, which is pretty crazy. Obviously, they weren't using as efficient of a model because it was deployed in the cloud. But then when they optimized it through us, it was able to be deployed across Android devices. The phone stopped overheating, and they actually went viral around the time of the Olympics, and they were the #1 sports app with over, I think it was, 85K downloads a day. They went very viral, which was super exciting for us to see. And that wouldn't have even been possible if they hadn't optimized their model, because it would have been deployed in the cloud and just being used after the fact. And it changed their whole business model of how they could use the model in their app and get real-time feedback, go do another swing, see the corrections that were suggested, and vice versa. So that was very exciting, and hopefully, you're able to use Qualcomm AI Hub in a similar fashion and go viral, and then let us know about it. So we launched Qualcomm AI Hub about a year and a half ago. What you'll see is we have over 1,900 companies using AI Hub today, which is great. And then we have our service collaborators and model makers that are increasing the AI Hub ecosystem. So after only 1 year, we've seen some great adoption, and we're hoping that after today, showing you how it works, you can also follow that trend. So I'll hand it over to Ashvin to show you how it works.
Awesome. Thanks, Megan. So up next, we're going to talk a little bit about how we've conceptualized the workflow that developers like you can use to get models running on device. So the very first step here is picking a model. And there's a couple of pathways you can use to do this. The first is to pick one of the over 250 pre-optimized models that we have available in our model zoo. If you're looking to use a different model, whether that's something you find in an open source repository on GitHub, something from Hugging Face, or even a model that you've built and trained yourself, we support a bring your own model pathway. The second step here is picking a platform. So what device do you want your model to run on? Is that a mobile device? Is that a compute device, IoT? The third step is picking a runtime, and which runtime you pick really depends on your use case, but we support 3 different ones. The first is TF Lite, TensorFlow Lite. The second is Onyx runtime, and the third is Qualcomm's proprietary AI Engine Direct runtime. Often we've seen that developers who are focused on Android tend to pick TensorFlow Lite as their runtime. So the fourth step in all this is testing, and I really want to emphasize that for this testing step, that this happens with hardware in the loop, and so you're testing that model on real hardware. The fifth step is deploying it, and this is where you folks can work your magic as developers and integrate these machine learning models into whatever application you have designed. So just to reiterate, with this workflow, within 5 minutes and with just a few lines of code, you can get your model deployed on real hardware. So next up, we're going to talk a little bit about what exactly those few lines of code look like. So we've designed our service so that you interact with it through our Python API. And so we've made a few different APIs available, and the first one we're going to talk about is this compile job. And essentially what this compile job does is it accepts your model, whether that's something designed in TensorFlow, in PyTorch or Onyx, and converts it into a runnable asset in the runtime of your choice, whether that's TensorFlow Lite, Onyx runtime, or Qualcomm AI Engine Direct. And so you'll see here the choices we talked about on the last slide. So you're picking which model you want to run, and that can be in the format of either a PyTorch trace or an Onyx model. You're seeing kind of the selection of which device you'd like that to run on. So here we've selected the Samsung Galaxy S24. And you're also seeing the selection of a runtime. And so in this case, we are picking the Onyx runtime over here. There's also just an extra parameter in there just to make it clear, where you pass in some data on the shape of the inputs that your model expects. PyTorch lets you set up your model with variable input shapes, but when you're actually deploying it on device, that's something that needs to be fixed, so we just collect a little bit of information from you on that. And one thing I do want to point out that happens during this compilation phase is that your graph gets optimized for your chosen runtime. And so, you may be asking, well, what does optimization look like? That takes on a lot of different forms, but one sort of very basic example we like to give is operator fusion. So modern machine learning graphs are huge. They're gigantic. And a lot of times you can come across ops right after one another that are maybe redundant. So for instance, maybe I'm adding a 3 with one op, and then immediately after that, I'm adding a 2. So during this compile job phase, when we're optimizing your graph, we might combine those two ops together into a single operator that adds 5. And that's a very basic example, but especially when you're talking about the scale of these modern machine learning models, we've observed that it makes a really big difference in terms of on-device performance. So the next API that I want to talk about is our quantize job. And this is sort of an optional step. So if you're working with very large models, or if you really want to minimize the runtime of your model or really minimize the memory usage of your model, you might want to consider quantization. So specifically, this does post-training quantization, which is very similar to static quantization in PyTorch. The one quirk here that I do want to point out is that this is Onyx model in, Onyx model out. Now, that doesn't mean you can't work with a PyTorch model. It just means that what you might want to do is first use our compile job to compile your model down to Onyx assets, run through the quantize job, and then after that, you can go back to the compile job and target whichever runtime you'd like. So next up, I'm going to talk about the profile job, and this is what you can use to determine real-life performance on target. So this uses the compiled assets that you produced with the compile job and actually tests how it performs on real-world devices. So in this case, you can see that we're targeting the Samsung Galaxy S24. And so in that case, we're actually going to go and procure a Samsung Galaxy S24 and run the assets that you've provided 100 times by default. And we're going to aggregate that data and use that to produce some statistics for you on exactly how long every inference takes, how much memory it uses, and where exactly on your chipset that model is being deployed. And so in the example that Meghan gave earlier about gaming, if you are a developer and you want to make sure that you're either targeting the NPU or the CPU, this is where that information would be very clear to you. So the last API that I want to talk about is our inference job, and this allows you to determine numerical accuracy on target. So once again, this takes in the compiled assets and the target platform. It also asks you to provide some input data. And so what happens when you run this is it actually, again, procures a real-life device that you've selected. It'll go ahead and deploy those assets and run through every one of the sample inputs that you've provided, and then makes the actual outputs from those computations available for you to download. And so just to clarify, this means that you're using your own data and your own metric. And so this can be something really simple that you do with this output data. You could compute something like PSNR, peak signal to noise ratio, or it could be a custom bespoke metric that's specific to your model and your pipeline. And so you can either do just a single sample for a spot check, or something like a full round of validation, just to confirm that during those compilation, optimization, and quantization phases, that the resulting assets you get are actually still producing what you'd want them to on device. So just to reiterate one more time, what this workflow allows you to do is take any model and any framework and get that running on device within 5 minutes and with just a few lines of code. So up next, we are going to try Qualcomm AI Hub together, and we're going to walk through a little bit of a demo. So I'll just switch to that. So before I do that, what I want to point out to you is aihub.qualcomm.com, and this is our homepage. So if you go here, you'll actually be able to find our full suite of over 260 pre-optimized models available for download. So definitely would advise everyone to check this out. We do allow you to filter by whatever use case you'd like and see if we have models that fit that use case. So with that, I'm going to go over to our example. And so right here, we have a Jupyter notebook, or excuse me, a Colab notebook available. And I'll provide a QR code to this later so that you can all run through this yourselves. So the very first step here is just pip installing QAI Hub, which is our Python package that actually makes those Python APIs we just discussed available to use. The next step is configuring your API token. So if you create an account at app.aihub.qualcomm.com, you'll be given an API token that you can use, and that essentially means that whenever you submit, say, a compile job or an inference job or anything like that, that it is actually targeting your account. So we've actually gone ahead and supplied that API token, and I ran through all the steps in here a couple hours ago just to make sure nothing was taking longer than it should have. But this is all something that you can run, and it should be very quick. One other point I want to discuss here is the list of devices that we have available for you to target. So this is a pretty long list, and again, would definitely advise you to check this out. We do have devices available across a bunch of different domains. We do have several mobile devices available, but we also do have some XR devices, some auto devices, compute devices as well. And so our hope here is that there is definitely a device for your use case, and you're able to get some good representative data across any devices that you are, in fact, hoping on deploying your application to. So for the purpose of this demo, we're going to be working with a MobileNet v2 model that we're just going to import from Torch Vision. And we're just instantiating the model. After that, we are doing a JIT trace. So like I mentioned earlier, sort of the entry points to what we're doing here with our compile job is either a JIT traced PyTorch model or an Onyx model. And so in this case, we're going the PyTorch route and obtaining that JIT trace. Here, we are also selecting the device that we want to use as the Samsung Galaxy S24. And now with that, we can actually go ahead straight into using that compile job API. So you'll see here that we are providing the model, which is that JIT trace torch model we just obtained. Our device, that's that Samsung S24 that we've specified. We're just providing some information on the shape of our model. We're just saying that it expects an image in this format. And we're also specifying our target runtime as TensorFlow Lite. And so, I can go ahead and submit this. It'll take maybe, like a minute or so to run. And what it provides you with, sorry, it got disconnected from the runtime, but I do have this compile job available that I ran a couple hours ago. And so this is what it looks like. This is the web page that it provides you with. One thing I do want to point out is the visualizer. So I mentioned earlier that our stack goes ahead and optimizes your model for on-device performance. And so that means that some operators might be combined, some might be a little different than what you expect. And so this visualizer is just a very useful way to go and see what the exact graph looks like that is going to end up being deployed on device through those runnable assets. And so this also provides you with a target model that you can go ahead and download. So in this case, that's just going to be a TF Lite asset. Now, the next thing that we're going to do here is a profile job. So we're going to take that compiled model, and we're going to go ahead and run it on device, specifically, again, on a Samsung Galaxy S24. So this is what that looks like. You can see here that it's reporting what exactly the inference time for this model is. It's running in 0.4 milliseconds. It's using up to 40 megabytes of memory usage, and all 70 layers on the model are resident on the NPU in this case. This also does have a visualizer that I think is very useful to look at. So in a lot of cases, you may see models where some layers are present on NPU, some are present on GPU, and some are maybe even present on CPU. But this visualizer makes it very clear by color coding every layer based on which exact compute unit it's deployed on. So in this case, they're all on NPU, they're all purple, but you would see the colors show up differently if the model was deployed on those compute units. One other point here from this profile job that I want to point out is our runtime configuration. So after the compile job, you have runnable assets. And if you want to be able to match the performance that the profile job has obtained with those runnable assets, all you have to do is use the configuration that's supplied here. So if you do this, you should be able to replicate that performance exactly. Now, heading back to the notebook, the last thing that we are going to do is actually run inference with some sample input data and confirm that the model is behaving with a high enough or a high model accuracy on device. So in this case, we're going to give it a sample image. We're just going to do a single input here. And specifically, what image we're going to give it is this example of a coffee cup. So we're just kind of pulling that image down. We are encoding it as a NumPy array and then going ahead and submitting an inference job with our compiled model, again, to the Samsung Galaxy S24 and with that image. And what we get, sorry, that's the compile job, is something like this. So again, it gives you some stats on inference time and memory usage, but in this case, what is more useful is the fact that it actually downloads the output data from running those inputs on target. And then we can go ahead and post-process this and actually see what the predictions of that model running on a Samsung Galaxy S24 looks like. And in this case, we can see cup and coffee mug are the two most common predictions, which tells us that our model is behaving the way we would expect. And so once that's done, we can go ahead, download those TF Lite assets, and I'm ready to go and drag and drop that into my application. So I know that it's performing the way that I expect, and I know exactly what to look for in terms of runtime and memory usage as well. So let's see. OK, so the next thing that I do want to talk about a little bit is AI Hub apps. So you may be asking, well, OK, that's great. I have this TF Lite model. Now, what exactly do I do with it? So that's where you guys as developers can work your magic and drop those into your applications. If you're looking for some examples of how to actually integrate these assets into your applications, or you're just looking for inspiration, we do maintain a collection of sample apps for you to take a look at. And so this is our GitHub repo. If you do want to actually deploy these on target, all you have to do is pull this repo. You can drop those assets in there, and you're ready to go. So taking a closer look at this, we've separated this out by Android and Windows, since those are both platforms that you can use assets from AI Hub on. So in this case, we're going to be focusing on Android, of course. And specifically, so the model that we just compiled, which is MobileNet, is actually a model that's compatible with our image classification sample app. And that's specified here, MobileNet v2. That's exactly what we were looking at earlier. And the way that this sample app is set up is all you have to do is go ahead and drop those compiled assets right here into the assets folder. And after that, you're ready to go ahead and deploy that on device. And so that's what I'm going to do right now. So when I ran, and so this is, I've cloned AI Hub apps, and I've opened that Android apps folder. This morning, as I was running through that Colab notebook, I went ahead and dropped my TF Lite file right over here. So now with that, I can go ahead and then just deploy it. I have a Samsung Galaxy S24 plugged into my computer. And we can see exactly how this works. So this sample app has a few images bundled with it. So in this case, Let's run this. We can see that it's classifying this as computer keyboard, mouse, or notebook. One thing I do want to point out is this is running on NPU, and so you'll notice that the inference time is under 3 milliseconds. If you do want to run this on CPU, you can, but you'll notice that the inference time is almost 10 times longer. And so that's what I want to point out here is that just by default, and actually it's even faster this time, is just by default, you're able to get the maximum performance using Qualcomm AI Hub to compile your assets. One other sort of sample application that I do want to point out is our tutorial for deploying LLMs on device. So we do have a tutorial over here that's called LLM on device deployment. And it showcases this whole end-to-end workflow where you can get actual assets for any of these models that are runnable on device. And so this, again, uses those same APIs we talked about earlier. Specifically, the compile job is mainly what's going on here in order to produce those runnable assets. This is available on our website. It definitely is a little bit more involved just given the scale of LLMs, but I definitely would recommend that you guys take a look at this if that's something you're interested in. So in this case, the one difference that I do want to highlight here is that we're targeting Qualcomm's AI Engine Direct runtime, not TensorFlow Lite. But at the end, we do have these sort of .bin files that are compatible with Qualcomm AI Engine Direct that we can actually go ahead and drop into another one of our sample apps, which is our chat app. So that's something that I will just run through right now. So our chat app. Okay, well, I already asked it a question, but I'll ask it again. What are, what is the best food to eat when I'm in Germany, or something like that? What food should I try when I am in Berlin? So as you can see, it's, oop, my bad. Let me just restart. Sorry, I think I unpaused into a, previously running question that I had. So I'm just going to restart. All right. What food should I try when I'm in Berlin? Okay, let me. Okay.
This is the problem with doing a live demo.
Yeah. Okay. What? Oh no, that's an emoji keyboard. Okay. Okay, there we go. That's what my problem was. So as you can see now, it's going ahead and generating a response for me. And again, I want to emphasize that this entire process is happening completely locally on my Samsung Galaxy S24. Yeah, it keeps going, but okay, good. I'm glad it said Curryverse. I was hoping that came up. But yeah, so we'll let that keep going, but that is what I wanted to show everyone. So next up, there's just a couple more things to run through, and then I'll give you access to the demo, and so that's something you can try on your own machines. So, all right, go ahead.
Yeah. We'll just put this back in presenter mode. A couple other things worth mentioning. As you've seen, we have a very extensive platform that you can bring any model to. With that, we've created just a simple Slack community so you can stay informed with the latest models. If you have a model that you want us to add to our collection of pre-optimized models, you can always request that. If you submit your own model to AI Hub and maybe it fails or it doesn't run in as fast as of a time as you would like, you can always just shoot us a message and ask there, like, hey, what's going on? Why did this fail? And we can look into it for you. It might be the op isn't supported in the runtime you've selected, and we can tell you, oh, try a different runtime, but our team can always take a look for you. And then it's also good to join just to know when we're deploying to our platform so that you don't try to, submit a model and then wonder why you get a white screen that gives you very small text telling you that we're deploying at that time. So join using the QR code. You can also visit our website, and there's a link there, so you can join that way as well. And we're happy to answer any questions. If you want to get started but don't have your laptop today, or you want to bring this back to your team and show them, we have 2 other resources for you. So the first is our resources page. This has a bunch of videos of cool applications like the one that I talked about earlier that are using Qualcomm AI Hub or have used it in the past, how they've used it. It's a good source of inspiration. We also have some how-to videos and some videos from sessions like this so that you can go back and rewatch and figure out, how to get started. If you just want the code snippets, you don't want to worry about anything else, you can head to our Get Started page and just walk through it that way, specify the device you're interested in, and get started. In case you wanted some inspiration in real time, here are some of the things that you'll see on our resources page. Everything from object detection apps to a blog about how to bring your model on device, and some of the apps that we've already talked about today. With that, we have 3 QR codes that we'll kind of go through here. The first is what we were just showing you with the Colab notebook, and it's the bring your own model approach where you can try submitting MobileNet. And the first step there is to go to aihub.qualcomm.com and create an account. So you'll see a sign up button, you'll hit sign up, it'll take you a minute just to put in your email and password, and then you can get started. We'll pause there for a second. We'll leave this QR code up. You can obviously try it today and ask us questions, or later in the week and shoot us a message on Slack. But we want to take the time to hear from all of you. What are any questions that you have, anything that we can clarify, or even models that you'd like to see in AI Hub models? So there's 2 mics in the middle of the room. Obviously, if you have a question, you can go to one of those.